Okay, so I'm really happy to be here, to be speaking in front of prominent group of fellow developers. My name is Piotr Nalepa, and today I'm going to speak about building framework agnostic UI with web components. Before I start, I have a couple of questions. One of them, most of you can answer right now. I already might know the answer. How many of you already know web components? Okay, so there's a couple of persons. And how many of you actually tried to build something with web components that is not like a small side project to check the examples? Okay. So, before I start talking about web components and UI, let me introduce myself. I'm senior software engineer at Out1 Polska. I'm also a blogger. I'm writing articles about web development since 2009. There's a lot of different articles, CSS, JavaScript, PHP, even Bash from the very old times. Yeah, and in my free time, I'm a great football fan. I play football personally. I'm a goalkeeper, so it was just because everyone else was scared of being hit by ball. Oops. Does it work? Yes. So, what is the story? The story is that have you ever needed to build UI that has to be reused across multiple different projects? And any one of you? Have you ever tried to build something? Yes. So this is a very common situation, and there are many tools that can help achieve that. For instance, there are tools like Bootstrap, Foundation, Semantic UI, and many different ones. But things like Bootstrap help to build user interfaces rapidly, but there are some caveats of using it. For instance, you have to be careful when implementing CSS to your project, because when you load CSS in an incorrect way, for instance, you are applying your own custom CSS at the beginning, and then you're applying the Bootstrap, then everything might be broken in terms of the UI. So it's very important to load the CSS in a correct order, and also you have to be sure that the HTML code required by the Bootstrap components is implemented in a correct way. The same goes for the JavaScript scripts that start the Bootstrap interactive Bootstrap components like models. This is very important to be aware of that. So, like I said before, there might be many different projects with similar UI. So you have to create the UI elements of that project every single time. Just like this. Here we can see the forms. These are three kind of forms: one from the Out1 website, one from the Facebook, and one from Amazon. So if you take a look at them, you can spot a couple of similar points, like the input field with the icon inside, or maybe the error reporting, or styled buttons. This kind of tools, elements, can be extracted to the custom UI library that can be built with web components. So regarding the Bootstrap, like I mentioned that earlier, that there are many tools that can help achieve the look and consistency in the projects, like Bootstrap. Like Bootstrap or Foundation or anything else. But it requires a lot of effort to implement such thing, because you have to think about the HTML, the CSS, and JavaScript at once. So yeah, so the biggest challenges of using these tools is to keep in mind that it cannot be you cannot leave any part of this implementation alone. So if you are applying the Bootstrap models, you have to keep in mind to implement the CSS correctly, HTML structure correctly, and JavaScript code correctly. So regarding the UI development challenges, this is a difficult topic because you have to think about many use cases. For instance, when I was creating a open source project where everyone was able to use elements for their own needs, for the project requirements that were different from the standard CMS project, I have to be aware that any kind of UI element that can be reused might not be used in the way I wanted to do. So, for instance, there might be for instance, a drop-down component. In the CMS, it might be just a list of categories. In other places, it can be, for instance, a list of places that contains a lot of information and a lot of possible actions that can be implemented. And it was difficult to think about these possibilities. Regarding the design consistency, having own custom UI helps to provide the design consistency. By this I mean the same feel and look in many projects. That can be really easy customized. For instance, changing the colors, changing the layout of the button, that kind of stuff. And also, having custom UI helps to reduce the code duplication. Because if you are working, for instance, for the project, like I mentioned earlier, for the Out1 website, for the Facebook website, for the Amazon website, and you are copying that elements, form elements across the projects, you are duplicating the work. Because each element has custom functionality, and each of them has error reporting, showing additional information, showing icons. It can be built as a custom UI that needs just small amount of changes in order to implement in different projects. So there's another part of this topic which is called agnostic. Who knows what does agnostic mean? Cool. So actually there are two meanings of the agnostic. The first one comes from the religion, which means someone doesn't believe in God. But in the context of the IT, agnostic means you don't have to care about the platform. So if you don't care about the platform, then it means you can use it in many different projects. That goes for the web components. This is the browser native technology. Yes. So the framework agnostic UI allows to build the design consistency across the projects, keeps the same functionalities working the same no matter the platform, and there is no need for extra code development. You create the UI once and reuse it in many places. Yes, so the code reusability also is that self-explanatory. So why the yes, I'm going to enlarge the screen here. Building the UI with the web components helps to avoid having many dependencies. You can imagine having dependencies like for Lodash, for Bootstrap, for instance, for the other libraries, for the script from the Bootstrap. Why? Because you're building something custom, something that suits your own needs, your project requirements. Of course, you can implement Bootstrap. You can implement anything you want, but it's up to you, right? If you are using Bootstrap itself, you have to load some additional stuff like jQuery, for instance, right? And by all these things that I have already talked, it all looks like a Bootstrap, right? So where is the difference? The difference is in web components. Web components consist of templates, shadow DOM, custom elements, and modules. This set of technologies allows to create cool UI that can be reused in many places, no matter the framework. You will see it later how it goes. Why web components? Browser native technology. So if you are if your target is to use in the modern browsers, then you are good to go. If you need to support other browsers like IE11, it's also possible. Here you can see the list of browsers that are natively supported. As you can see, the edge is needs some polyfills in order to use web components in the projects. The next win with web components is UI element as HTML tag. What does it mean? It means this. So instead of having huge structure for the modal or something from Bootstrap, I'm going to refer to Bootstrap because it's very common and very popular. Instead of having huge structure of HTML in everywhere on every page, you can just attach the custom HTML tag. In this case, this is a St. Peter notification. It's the tag that allows to implement the notification feature. And everything that is rendered inside the notification tag will be displayed as a children of this element. So the implementation of this feature is hidden behind the tag in the HTML. So you don't have to load the additional CSS, you don't have to load JavaScript, you don't have to think about the HTML markup you have to implement, you just add the tag to your HTML code. So web components has some support for the server-side rendering. It's very simple to use, like I showed a while ago. You just put the tag into your HTML code. But when debugging, you can see something like this. I have turned on the shadow root, the visibility of the shadow root. So in this case, you can see three parts: the HTML tag, the shadow root, which means in this case is opened, and the children of this. When you open the shadow root, you see whole the HTML structure of the element that is needed to render the functionality. And the structure of the St. Peter notification element is hidden behind the shadow root. Why? Because of scoping. In this case, you can have your CSS scope. You can have HTML structure scope. You can have JavaScript implementation of the feature scope. So it does the code doesn't collide with the parent code. So for instance, if you decide that every link inside the St. Peter notification has a green border, for instance, by applying the CSS code from parent, it doesn't override it unless you allow it. So, creating reusable web components It's kind of difficult. I mentioned that earlier, but it's possible. Why is it difficult? Because you have to think about all the possibilities it gives you. Yes. Here you can see sample implementation of the web component. On the presentation a couple of hours ago, you could see something a bit simpler without shadow root, without these callbacks. And on the next slides, I'm going to explain you what does these callbacks are for. They are for the component lifecycles. So, how many of you have ever written a component in React, Angular, or Vue? Yes, a lot. So, like in these libraries and frameworks, web components have own lifecycle. The first lifecycle is the constructor. There you can initialize all the properties for the component, but it's still not rendered. Just like here. What I'm doing here, I'm just calling the constructor, calling the super method, so all the properties from the parent component that it extends are taken into account. And also I'm opening the shadow DOM, which allows me to scope the CSS and JavaScript. And I'm applying the template to the shadow root. So by applying the template to the shadow root, I'm just hiding the implementation of the component behind some kind of curtain. There's also a connected callback. This callback is very important to detect the moment when the element is just inserted into the DOM structure. So when the element is added to the DOM, you can query the elements from the template. You can attach event listeners, and also you can start fetching data from the external resources. The disconnected callback is the opposite of the connected. Here you should clear your all event listeners. You should clear your requests just to avoid having mess in the code. There's another one, attribute change callback. This is something similar to component did update in React, because it detects the changes of the in React we have props, here we have attributes. So here we can detect if the attribute with name of type had changed, and I'm console logging this. I see there is a typo, so sorry for that. And there is one last callback, rarely used, but I wanted to mention that. It's adopted callback. What does it use for? What is it used for? In most cases, it's used when you are changing the parent of the element. By this, I mean if you are copying from the, for instance, your blog website to the page that is displayed inside the iframe that is embedded on the website. So in such situations, the adopted callback is called, and you can do whatever you want whenever the parent changes, because it's all about the window that is the parent in this case. So to start using the web components, there are two ways. One way is to just include the web component polyfill to add the support for all the browsers, and just to add the component itself to the HTML structure. If you don't have to support all the browsers, then you can skip the first line here, because it's just the polyfills. And here is my sample web component in action. It's just for displaying notifications with the closing button. Very simple, nothing sophisticated. And yeah, web components plus JavaScript frameworks and libraries. How to deal with them? I'm going to show you. Surprisingly, it's very easy, despite one one case. Yes, it's possible. And custom elements with React. Custom elements is just web component tag. So anyway, we can have we can create just application, React application with the HTML tag St. notification inside. What is very important here is that you cannot use React like even handlers because React doesn't recognize the web component functionalities here. You have to get the reference to the element and just attach the event listeners the traditional way with the events. This is the small trade-off of using web components in React. Just like native. Custom element and view, also the same way. You're rendering the custom element inside the view component, and that's it. And you can handle all the events and the way it works similarly to React. But with Angular, it's a bit different. Why? Because Angular by default provides some kind of web component functionality. If you try to use the external web component inside your Angular code, you have to add a configuration for it. Here, when we are defining the ENG module, you need to add the custom element schema from the Angular core in order to allow Angular modules and components to recognize your custom web components. Without it, Angular will be breaking, shouting that it doesn't recognize the components you created because it doesn't have the reference to the file with the web component. And yes, you have. I was using the Angular CLI, so I needed also to add 2 more lines. For the CLI config, I was adding the web components bundle and St. notification component. And after this, when everything is in place, I was able to use web component inside external web component inside Angular component. This is kind of inception because Angular implements web components, and I was using my own web component from external resources. What is worth to mention that Vue also implements a kind of web components technology in its library, but it doesn't collide with the standard browser native implementation of the web components. So, if you want to support all the browsers, I really suggest to use the polyfills mentioned on this website. Here you can, of course, load just the things you need. So if you support only everything else except IE11 and other browsers, then the supported the polyfills required to load there is less polyfills required to load. But in the case of for supporting IE11, IE10, and mobile browsers, you have to load more polyfills. But it's not very. It doesn't increase the size of the website very much. Web components itself is very repetitive when writing the code manually. So you can use the web component frameworks like lit-HTML, Stencil, Skate.js, and many other web components that are not that popular. I'm not sure if you heard about this story that Apple implemented web components on the production website. Who heard about this? Okay, one person. So there are companies that are already using the web component on production, and in the case of Apple, they are using the Stencil framework. This is extra thing. How web components can help us to build the to use the micro frontend architecture in our application. I'm going to tell you about this, but first some explanation about the micro frontend architecture. In this approach, web application is broken down into small features, and these features are a kind of small applications inside a huge monolith application, and each feature is owned by the front-end to back-end team. So each team can make decisions on their needs, on requirements, etc. This is the picture of that shows how the micro frontend architecture might be implemented. You can see there are three groups: the micro frontend Angular, the micro frontend React, micro frontend Vue. If you are interested why each micro frontend uses a different framework, it is because each feature is a different application. So for instance, micro frontend Angular is responsible for building the forms on website. Micro frontend React is responsible for building, for instance, advertisement widgets, and the micro frontend Vue team is responsible for building, for instance, website navigation, application navigation, navigation of the application. So each team can decide that they want to use that particular framework, and they keep the continuous integration and deployment on their own without looking at the other teams. What is really important here, that it would be very irresponsible to use three different frameworks on the same page because of increased payload, of the increased site size. Yes. So on this slide, I'm going to explain you why the application per feature. You can imagine that you have a huge monolithic project with a lot of features, right? So having the micro frontend architecture, when you have a lot of developers in your teams, help you to split developers' work into smaller teams. They become independent, and they know what to do in order to apply a specific feature to the application. So here we have the feature ownership. Each team knows what to do. And we have the independency, which is really important in the case of building teams, because I met it many times that developers love to argue about the technologies, right? So here you can build the team that is using a specific set of tools and make them happy. They are working effectively, they are delivering a feature, and they help to progress the business. So what are the micro frontend pros? Simplified web development, I mentioned that earlier. By having, if team can decide what they want to use in order to implement such a feature, it's very easy for them to develop features, because if they don't like the technology, it takes more time to develop something, or it takes more effort to develop something. It generally simplifies the web development. And the code is self-contained. What does it mean? It doesn't affect the global scope, right? So you don't have to share the runtime. You don't have to have shared state or global variables. You're building an independent application inside a huge application. And there is a independent deployment, which helps to deliver features faster, because you don't have to care about the other features that might be broken by your code, because your code is independent, right? And as higher order benefit, teams are autonomous. They can decide what they want to use, and they own the code, so they can specify the tools, which is very important, and you can make them feel happy. Yes, autonomous teams. What are the cons of the microfrontends? Of course there are. Microfrontend architecture is not so good for the smaller teams. Why? Because if you can imagine having a team of 5 developers, 2 developers for the front end, 2 developers for the back end in one tester, then it makes no sense to divide such small team into micro front-end architecture, because there is no need to, right? The payload size, I mentioned that earlier, that loading 3 different libraries framework would be irresponsible. So you have to think about how to solve this situation. So one of the proposed solutions is to have a kind of contract between teams, just to avoid a situation when you are loading the Angular, React or Vue library on the website. You might be thinking how this affects web components. We'll get it later. And also the environment differences, so-called outdated projects. Sometimes the team might be developing features without knowing that something had changed in other projects. Why? Because it doesn't affect their project, but it might be useful for themselves in the longer time. So micro frontend and web components, good to go? It depends. It depends mostly on the projects. But if you have a big team and you want to build something that is reusable across multiple devices, browsers, etc., then it's good to go. Why? Because with web components, you can build the UI that can be reused across multiple micro apps. Also, you can use the web components just to load your micro frontend application inside your monolith application. So, for instance, I mentioned iframes, right? Iframes are is one way of implementing the micro frontend architecture. So, if you are loading the iframe, you can just create a web component that initializes this iframe with proper configuration, and you don't have to expose the internals of the iframe to the end user. So the takeaways of web components and web components: you avoid the UI code duplication, because you're building once and use it everywhere. You can start thinking about the UI consistency, which is very important. You can save your time, because you don't have to spend time on developing features. You don't just reinvent the wheel. In order to implement the web components correctly, I suggest to follow the checklist, which is defines the gold standards. Some of the rules are not filled, but most of them are good to use. And yeah, following this list helps to build web components in a good way, so they are error-proof and they work in every environment. And the last thing, take away from this speech is, if you follow the micro frontend architecture and web components, then companies can hire different developers from different domains, because you are building Angular application, React application. You are just loading the stuff with web components, right? So there is no problem of hiring developers if you are limited, just like in the situation when you are limited to the specific technology. So that is all for this presentation. Where you can find me? You can find me on my blog. You can find me on Twitter and on GitHub. And slides for this from this presentation will be shared later on Twitter. Do you have any questions? At Out1? Not yet. Because we are now moving to the micro frontend architecture. We are going to use web components for this. And yes, so this is the direction we are going. Okay. Any more questions? No? So thank you very much.